Hi, welcome to Nomis Academy. In this video, we'll be dealing with subtraction of binary numbers. Subtraction of binary numbers. I want you to remember that in binary numbers, 1, 2, 3, 4, 5, 6, 7, 8, and so on like that are just 1, 10, 11, 100, 101, 110, 111, 1000, like that. So that's how it continues. For in binary numbers, we do not have any other digits than 1 and 0. So let's take some examples to see how subtraction of binary number works with the digits of binary numbers without 2, 3, 4, 5, 6, 7, 8, and other numbers apart 1 and 0. So let's take example number 1. Subtract 10111 from 111101. So subtract this from this. So let's get on to the solution. So 1, 1, 1, 0, 1. We're going to take our kindergarten method of subtraction and addition to get this done. So this is 1, 0, 1, 1, 1. Be careful to start from the right hand side and not from the left, so that you would not have it elapse at the right hand side. So it must be that all is filling from the right hand side towards the left hand side. So what are we doing? Subtraction. So remember that these are in base 2. So 1 minus 1 is definitely 0. Nothing is left. But 0 minus 1 is not possible, right? So we have to borrow 1, that method now, from our kindergarten. So 0 plus 1 is not possible. We'll borrow 1 from here like we borrow, and then we'll put it here to make it 10. So this becomes 10. 10 minus 1, it is not 9, it is 1. Remember, here 2 is 10. So 10 minus 1 is 1. 10 minus 1 is 1. So what I'm left here is, I'm left with 0 here. Remember, I borrowed this 1, so I'm left with 0 here. So I have to borrow 1 from here to subtract 1 from it again. So if I borrow 1 from here, I will have a 10 here. So I borrow 1 here. This is a 10 now. 10 minus 1 will still be what? Good. 1. Remember, this is 0. 0 minus 0, no problem, I can write 0. So what I'm left here is 1 minus 1 is 0, and nothing to subtract from this one. I'll keep it down, and that is my answer. 100110 in base 2. How am I sure that my answer is correct? Let me go and convert each of these binary numbers to number in base 10, subtract this from this, and then convert my final answer to number in base 2. You will see we are going to end up having the same answer. But that will be a long process. But just to confirm our answers, let's do that now. So 1 multiplied by 2, 1, 2, 3, 4, 5 raised to the power of 5, plus 1 times 2 raised to the power of 4, plus 1 times 2 raised to the power of 3, plus 1 times 2 raised to the power of 2, plus 0 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. So everything here is 32 plus 16 plus 8 plus 4 plus 0 plus 1, because 1 times 1, 2 to the power of 0 is 1, right? So 1. So 32 plus 16 is 48. 48 plus 8 is 56. And 56 plus 4 is 60. 60 plus 1 is 61. Everything here is 61. So let's convert the second one. 1 times 2 raised to the power of 4 plus 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. So everything here is 16 plus 0 plus 4 plus 2 plus 1. 1 times 1, 1. So 16 plus 4 is 20, and 20 plus 3 is 23. 23. So 61 minus 23 will have 38. Correct. So 61 minus 23 is equal to 38. So let's convert 38 that is in base 10 now to a number in base 2. We should have this digit. So let's go. How do we do that? 38 divided by 2. So we take our remainder as our binary number. So 38 divided by 2 is 19, remainder 0, right? So 19 divided by 2 is 9, remainder 1. And then 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And then 1 divided by 2 is 0, remainder 1. So we take our answer upward. So that is 100,110 in base 2. And that's our answer. You can see we arrive at the same answer, 100,110. So we just find the subtractions of the numbers. Let's take another example. Example number 2. The question says, calculate the difference between 1110 and 101. So this is a simple one. So to calculate the difference, we still mean that we should do subtraction, perform subtraction. So that will be 111 is 0 minus 101. So can I subtract 1 from 0? No, I'll have to borrow from here to make it 10. So remember, 10 minus 1 will be 1 in this case, a binary number. We are left with 0 here, right? So 0 minus 0 is 0. So 1 minus 1 is 0, and I'm left with this. So 1, 0, 0, 1. So how am I supposed to be sure that this is correct? Let me convert each of these to the base number in base 10, and then subtract them from each other, and then convert my final answer to number in base 2 to see if I'm going to have this. So this is 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. So everything here is 8 plus 4 plus 2 plus 0 multiplied by 1 is 0. So 8 plus 4, 12 plus 4, 2, that's 14. 14. So here we have 1 multiplied by 2 raised to the power of 2 plus 0 multiplied by 2 raised to the power of 1 plus 1 multiplied by 2 raised to the power of 0. So everything here is 4 plus everything here is 0 plus everything here is 1, and that is 5. 14 minus 5. is equal to 9. So everything here is 9. So let us convert 9 that is in base 10 to a number in base 2. So what we do is to divide 9 by 2, take the remainder as the number in base 2. So we say 9 divided by 2 is 4, remainder 1. 4 divided by 2 is 2, remainder 0. 2 divided by 2 is 1, remainder 0. And 1 divided by 2 is 0, remainder 1. So take our answer upward. So 1001 in base 2. I know you might say, even if I take my answer from the top, if you take it that way, it might not be correct for some others. So that's why this general rule is taken, that you take your answer upward, 100 in base 2. I believe you understood everything we did in this video. Bye bye. See you in the next video.